Good evening to everybody. My name remains Timothy, and I am the coordinator of this training right from the inception. This night, we're going to continue from where we stopped, or perhaps we're going to start a new subtopic, which is a machine learning, which is a deep learning tonight. I would like to introduce our tutor to you tonight in person of Ayobami. Please, Ayobami, take charge as we start recording now.
We are going to start the real deal, which is deep learning. So I'll share my screen now so we can start. Yeah, I think we can all see my screen. I think so.
Yes, we can see your screen clearly.
Yes, sir.
Okay. Let me try and. Just one moment, please. Okay, can we see my screen in PowerPoint display? Okay, is my screens big enough?
Yes.
Very big. It's okay.
Okay.
Yes, sir.
Yes, sir. We can see,
Okay.
sir.
Good. So we are going to go into deep learning with Python, which includes practical illustrations. So basically, we are going to first of all talk about introduction to neural networks. So we want to know about what neural networks are and what deep learning is, so that we can get the basic understanding of what deep learning is. And then before we go into the architecture itself, where we have CNN, convolutional neural network, we have RNN, recurrent neural network, autoencoder, and the rest. So now, what we want to learn is we're going to learn the fundamental concepts of deep learning and implement some deep neural networks in Python. And we're going to work on basic projects and progress to more advanced ones, and how to share our codes on GitHub. So if you don't have an account, we'll create one. So I don't know, most of us here must have heard about GitHub. So GitHub is for developers, or data scientists, so where you can share your code or drop your codes in case you want to showcase your code for those that are hiring, so they can actually see your portfolio and see, okay, what you have worked on before. And we'll talk about how to conduct research and publish the results on high quality venues. So how to conduct your research in deep learning, so, and how to um, gather out the result and publish it. So, and like I said earlier on from the beginning, I said we are going to create some teams project to work on. So before we move ahead, so what I'm going to look into now is the introductory aspect to neural networks first. So I'm going to talk about neurons, the basic units of a neural network that receives inputs and apply weight and produces an output. So that's what a neuron is. So it's just the basic unit of a neural network. So what it does is just to to get input, and it applies weight based on how we structure it and gives us an output. And we also have layers. So Now, I want to talk about layers. So, neurons are organized into layers, such as the input layer, the hidden layers, and the output layers. And we also have the activation function. So, and which is applied to the output of a neuron to introduce non-linearity. And common activation functions include the ReLU, which is very Sigmoid also, which is very popular, and Tanch, which is also popular. But the one that is mostly used is the ReLU and the Sigmoid activation function. So when we talk about neural network, we are going to be talking about these three things often. So the neurons, layers, activation function. So we're going to move into what deep learning is. So, what is deep learning? Now, if you look at this image on the right hand side here, so we have artificial intelligence, which is known as AI, and we have machine learning. So, you look at it here, machine learning is a subset of artificial intelligence, and while deep learning is a subset of machine learning. So now, what is deep learning? So it is how to enable computers to mimic advanced human capabilities. So that's what deep learning is about. And also learning AI rules by analyzing collections of known examples. And is a type of machine learning that needs to be told about the essential features. So what deep learning does is that it operates like the human brain. So that's why when we talk about the word neurons, so which I'll still show us the function of a neuron. So there is a Jupyter notebook that I will show us. So we're going to see that in action. So, but basically, deep learning actually goes way beyond just the machine learning, where we just only talk about algorithms, where we talk about um, that is we talk about logistic regression, linear regression models, and so on and so forth, like that. So, but when we talk about deep learning, we're talking about neural networks. Yeah, where we look at training larger data sets in order to mimic advanced human capabilities. So now we are still on what is deep learning. So now, still on this, machine learning, which is ML. What machine learning does is using parameters from known and important features of data and used to predict the outcomes on similar data. And the final output itself is called a model. So that's the way a machine learning operates. So it uses parameters from known and important features of data, just the way we have seen from the machine learning recap, and it's used to predict outcomes on similar data. So, and the output itself from the pattern it has learned is what we call the model itself. So that's what machine learning is. But if you look at deep learning, it's about using artificial neural networks, and it is learning tasks directly from raw data, and it needs better hardware and data. So basically, for deep learning, we it's actually what it does is it learns tasks directly from the raw data. It's just like, for example, when you give birth to a child, the a child itself doesn't actually know anything. So, but when the child starts growing up, then in his environment, then the child starts learning to know how things operate, how it doesn't operate, how things work. So the constant learning and learning, and it helps stimulate the mind of the baby. And before you know it, the baby already learns some task directly from some things, how they work. So, and the more the data or the exposure of that baby, then the more firm the baby can actually predict. So, for example, me just seeing one dog and saying, okay, this is a dog, is not enough to say that I know about dogs. So it's I must have known different species or different breeds of dogs for across different countries or in the whole world and continent. So that's just the thing that has to do with deep learning. So and it needs better hardware and data. So which we are still going to talk about. So now we are still on what deep learning is. So now the question is how to learn data. How does deep learning model operates? Now the thing there is that it uses the features existing in data. For example, images, sounds, etc. Can be anything. So and what it does is that it is trying to find the rules and patterns. So there are rules to the way images are aligned or structured, and there are patterns as well in images and sounds. So that's what the deep learning architecture tries as much as possible to learn. And also it's decomposing existing features. So it tries to break it down to decompose it so it can learn from it. So and if we look at this, we have pixel based, yeah. So it can be a low level feature. Once say pixel based, that means images. So and we from the low level feature, it moves to a high level feature. So and when we have object based is a high level feature. When we have objects, something like let's say a ball, a football, something like a car. No, those are objects. So what exactly it tries to do is to learn the rules and patterns so those features. So now when we look at low level features, for example, these are low level features here. And low level features are something like edges, dark spots. So edges and dark spots, examples of edges and dark spots are these. For example, if you look at let me see edges there. So and those edges are peculiar. For example, if I want to create a facial recognition system using a deep learning architecture in such a way that when I want to enter my house, so if the scanner, the computer vision the model that I created scans my face, so if it doesn't spot the edges or the dark spot on my face, then it won't actually open the door. It won't be able to I'll say or identify, okay, this is me. So, but if it can actually spot the edges and dark spots on my face, then that means that um, it can give me clearance to enter into the house. So, and when we talk about edges and dark spots, these are low level features, which we will still see. Now, we'll talk about mid level features, and they are eyes, ear, and nose. So as you can see here, they are mid-level. So the eye, the nose, and the hair, those are mid level features. And while the high level features itself are, when I say objects, so it means the whole face itself, the facial structure. So now what deep learning learns is features. So and it learns features from images, sounds, or objects, anything by trying to decompose the existing features as low level features, which are edges, dark spots, and mid-level features like the eye, nose, and ear, and the high-level features like the facial structure itself, trying to understand it. So now, this we are going to look at um, this perspective. How does classic machine learning works and how deep learning works? Now, for example, now if you look at this classic machine learning, we have a feature here. This is a high-level feature, and it's n by n. So, and here now we can see that when we pass in this phase, what it does is that what classic machine learning does, it turns this into a function actually. So which f1, f2 up to k, function k. So here now, roundness of face, the distance between the eyes, the nose width, eye socket depth, cheekbone structure, jawline length, etc. Those are the function. Like for example, roundness of face is f1, f2 is distance between eyes, f3 nose width, and so on and so forth till when we already have all the whole features already described. So, and all these things are features that can be classified by an machine learning algorithm. It can be anyone, which is the support vector machine, or the random forest, naive Bayes, decision tree, and logistic regression resemble methods. And then we have a mark, which is the model itself. Then we can now bring in another phase or a phase similar to this to see maybe it actually predicts. So, and this itself is just like changing this face itself, changing it into a feature that is understandable by the machine learning algorithm, which is a number itself. So how can we convert this into a number? So that's we are not interested in this, but I will show us something related to this, where we will compare machine learning and deep learning, training machine learning model and deep learning model with the same data. So we're going to look at that. So now looking at deep learning, what deep learning does is that it takes in this image and it passes it in into the neural network. And like I said, when we talk about a neural network, it consists of the neurons, the activation function, and the layers. So now we have the input layer. Now, what the input layer, this face is going to be turned into um, numbers. Example of numbers, I mean tensors. So this face is going to be turned to a tensor, something that the neural network understands. So it's going to be at the input layer, and then the all the hidden layers are what is going to learn all the features that has to do with the face. So we have the first hidden layer, the second one, the third one. There can be as many as possible hidden layers depending on the strength or depending on the architecture or what we are trying to achieve. And then we have our output, which is this here. So, and one thing there is that we have to feed this neural network with millions of parameters, because the more the parameters, then the more stronger the model, how it can be able to predict. So, and then we now have the model which we can use to predict or feed it with any fish, and it will be able to predict. Okay, this is so 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 person. This is not so 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 person. So that's the way deep learning operates, which is different from the machine learning. So machine learning is different from deep learning. They are not the same. They are different. So machine learning talks about algorithms, which classifies, and while deep learning is about neural network. So those are the clear difference there. So now we want to talk about the requirements of deep learning. So what are the requirements for deep
Before we
learning?
continue, I would like people to ask
Hello, sir.
questions. Hello, hello,
Hello,
hello.
sir.
Before we continue to go deeper, I would like people to raise their hands and ask questions. This is the foundation of deep learning. If you don't understand the foundation, you can't understand the code. It is so. It is what you know how is being performed operationally. That is when you can now know what the code is all about. If you don't have the framework, the patterns of how it's being operated, you may find it difficult to understand the coding. So please, let's ask questions at this stage. I would like to ask questions on this stage. Not that at the end of
Okay.
a training, let me begin to ask questions. So if you want to ask a question from each of the slides, each of the page of the slide. Please ask questions.
Okay, let me ask at once. Thank you very much. Please, you said the output of a machine learning exercise is the model, right? Now,
Yes.
what is the end product of deep learning exercise? That is question one. Then question two. Um, so machine learning, and I think there is a neural network before deep learning. So my question is deep learning part of somehow? Because I would have preferred, it would have been nice if you actually explain what neural network is before now talking about, I mean, briefly, not into depth, before now talking about deep learning, so that we actually place things properly, understand how things are properly. Because you're using neural network to explain deep learning, so it would have been nice if, in general, you understand when you start talking about deep learning. Thank you.
Okay. About the neural network part, this slide is 68 pages. So, and everything is about neural network. So we'll discuss that. So we are just getting into it. So it's gradually. So I'm just laying some foundations. So I've not done justice to it yet.
Okay, that's good.
So that's about that.
That's good.
The end product of deep learning exercise.
Yes, it's also a model as well. It's a
Okay,
model.
thank you.
Yeah. So is there any other question?
Oh, please can continue. If nobody has any question, continue, please.
Okay. So we want to look at the requirements of deep learning. There are three things are very important when it comes to the requirements for training a deep learning model. So number one is bigger data sets. Number two is better hardware, and number three is efficient software and smart algorithms. So when we talk about bigger data sets, now to extract the features, we need to have all variations of data and large data sets with thousands and millions of samples. Now, I don't know if you have ever experienced this before. Some of our phone, it has facial recognition software or ability where you use face lock your face to unlock your phone. So, and if you notice when you are trying to use the lock, when you are trying to use the lock to put it on the phone, you see that it will say you should put your face, and it said you should still station your face. It's trying to learn the features of your face and extract the features. So just imagine it just takes your face, just takes the picture once, and it did not study the structure. And for example, maybe someone now fall down, and my face now swell up. So do you know that it won't be able to, like, the facial recognition will not be able to identify my face due to the variation in my face. So because my face has swollen up. So, but the fact that if I can feed it with, okay, maybe facial recognition system whereby it has different features of when um, I just woke up, when I'm asleep, or when I'm smiling, when I'm happy, when I'm crying, all those stuffs like that. So those are the variations that we are talking about. So, and if you want your phone to perform very well, you need features that are very big. For example, if you want to train a deep learning model, depends on the project actually. For example, plate number recognition. If you want to actually create a software, a deep learning model that can recognize plate numbers. So that means you need the database for, that's federal government database that actually has to do with plate numbers for all the whole cars in Nigeria, so that when it actually picks up the plate number, when a camera picks up the plate number, it can be able to give us the information about the driver, the age, the state where the driver person lives, and everything. So, and how we can achieve that is having a very big data set. Just few numbers of data set cannot achieve that. So it also has to do with having thousands and millions of samples. So that's what sets deep learning apart from machine learning. So machine learning can still make do with just few samples, but when it comes to deep learning, to have a very strong model, you need thousands and millions of samples with variations. And the second one is a hardware, a better hardware. We need a highly parallel, sizable hardware. So to process the big data, and your system, your space on your system, the core. So at least you need core i5. If you want to run something very, very big, so you need some core i5, i7, i9, then you need 16 gig RAM. Yes, so but you can still make do with, if you are not training a very big data set, so you can still use 8 gig RAM. 4 gig RAM is not advisable because it will be using most of the resources so on your system. So basically, you need 8 gig RAM, at least 8 gig RAM, and need let's say the hard disk size can be 500 gig or going to 1 terabyte, or anyhow it's just how it suits your power or maybe the spec of your computer. And you can use core i5 above, or you can still use core i3 if it is still small data you are still trying to train. It just depends on the project. So and the GPU, GPUs are the best options. So we'll still talk about GPUs. So which is graphics processing unit. And when we talk about GPUs, yeah, that's when I'll give us an option to use Google Collaboratory. So we'll still get back to that where I'll explain why we can use Google Collaboratory, because they have a lot of GPUs that is free that you can use. So instead of you using your own PC, so you have a lot of GPUs to use that is very free on Google Colab, and it can aid and make sure your model is being trained very fast due to the available resources that they have. So efficient software and smart algorithms, toolbox that enable us to process big data using GPUs, and that is different toolbox like we have the TensorFlow, we have the Keras, we have the PyTorch, and so on and so forth. So platforms like I said, we have Teachable Machine, we have Google Collaboratory, and so on and so forth like that. They are countless. So, but the ones that are very common is Google Colab and Teachable Machine, where you can teach your model, your data. So you feed it in with the data, then it trains the model. So the things that are very important is the data sets, the hardware, and software and smart algorithms. So I don't know if there's any question about that before I move on.
Let's move on, please.
We are
All
clear.
right. So now, about what I was saying, that what are requirements of deep learning? You said big data plus powerful hardware and efficient software. So when we say big data, I mean very big data, something so big, so big. So this is an example of big data, but this is just showing variations of different things. So, for example, we want to train, let's say, a model that recognizes animals or human beings. So that means, or anything at all, we need to feed it in with data that is so big that has almost, let's say, for example, we can collect data, we have access to Facebook data, Twitter data, and the images there. You can use it to train, and it can identify people's faces, names, and everything. So that's one thing about the big data. And that one is, like we said, powerful hardware. Some hardware like MSI. MSI, if someone is using MSI system here, they have have a very power that can aid the processes very fast, so we can train our deep learning model. Sometimes train very fast. If you don't have a very powerful hardware, then it's going to take time. That's why sometimes you can train a model for 1 week or 2 weeks, depending on your hardware. If you just feed it in, so you have to wait, and you must not allow power to the system to go off because it is still training the model. So the powerful the hardware, the faster it will be.
Hello, please. I did not hear anything again. Probably the internet from my side is off, so the recording must have been affected by that. Are you there?
I think the tutor
Yes,
lost
here.
connection or something.
Or maybe it's from his end. I did not hear
The
anything.
network is very poor.
I did not hear anything
Yes,
again.
it's from his end.
Yeah. So let's wait. Let me pause recording.
I want to put it in PowerPoint display mode.
Please continue teaching. I'm recording already.
Okay. I think we can see my screen.
Yes, we can see it vividly.
Yes.
Okay, so we're talking about the requirements we need, and we're talking about hardware. So, and I said that.
Um, I need a, so, sorry, sir. I need a, I'm sorry, sir. Sorry to interrupt,
What do you say, sir?
sir.
What do you say? What do you need?
Excuse me, sir.
We are with you. Please continue teaching, please.
Sorry, sir. I can't see the presentation, sir.
You can't see it. Then log out and log in.
I cannot see what is being displayed, sir.
Please log out and log in. There is your service. Log out and log in. Please continue teaching.
Okay, so like I said,
Yes, sir.
you said that
Okay, sir.
hardware is part of the things that are very important when we are dealing with deep learning
Okay, sir.
models. So the better and powerful the hardware, then the better it is that we can train our deep learning model very fast. So, and like I said, if you don't have the money to buy an MSI system, so which is actually designed for deep learning to train deep learning models, then you can use the Colab. Yes, the Colab platform where we can actually have free access to powerful resources. So, and most especially, a lot of people use Colab. Exactly. So we'll focus more on this. Although we'll do some lightweight deep learning training on our system to get to computing very fast and having access to more resources. We'll use Colab. That's when we are dealing with more images. So now talking about the efficient software. So software in this aspect has so and then the software we want to use, we want to use TensorFlow, we want to use PyTorch, we want to use Keras. So and MATLAB also can also be used to train deep learning models, but we are not looking at MATLAB. With software libraries that we can use to
Hello?
models which are very powerful, TensorFlow,
Yes.
PyTorch,
The
and
reason why I
Keras.
said we
So
should
we're going to
pause
focus
recording
more on
is
this,
because
these three.
I should be in class. I'm in class now. I think people should be
So
hearing what they're saying here.
um,
Between 9 and 10. Yeah, my
well,
thinking was by 9 or
we
past 9.
got it as matter.
I'll call you myself
So
by 10. or are you sleeping data period?
Like held images. Example, ImageNet has a 10 million labeled recognition system. So million categorized videos. So these are what we are talking about. Bigger data set. When we say big, we mean something like this: 10 million, 8 million, 2 million, hundreds of thousands of such nature. And better hardware. So hardware that obey Moore's laws. So and the cost of from per gigabyte in 1995 was $1,000. So you can have access to them. So, but it's better to buy systems that are tailored into deep learning things that can actually do deep learning modeling or training. So, example of that is MSI systems that are already tailored that we have built for deep learning. So also we have smarter algorithms and the likes of CNN, convolutional neural network, RNN, recurrent neural network, and LSTM as well. RNN and CNN are very common algorithms used to train deep learning models. So the fundamental concepts now, we said artificial neural networks, which is ANN, or simply called neural networks, is inspired by um, the human brain. Yes. So there's a way the human brain operates, and the human brain in such a way that it is interconnected with each other, and that is because of neurons. So the way neurons interact. So that's just the way the deep learning concept is. So it talks about neural networks. So now when we talk about artificial neural network, it's we are talking about it being contains a artificial neuron. So and this artificial and gives us an output. So as it takes in the input, it processes it and it generates an output signal. So and can several artificial neurons can be connected just the way it is in the brain, whereby neurons connect with one another and interact with one another. So the output of a particular neuron will be the input of another neuron. So just so that they can interact, and interaction, it's in an organized way forms what they call multiple layers. So that layer is in itself is called the artificial neural network itself. It creates a network where we have neurons connecting to one another and one another. So just like we saw in this place, just something like this, neurons connecting with one another. So now I want to talk about the perceptron. Now, what is a perceptron? Now, it is the most straightforward architecture network. So, and what it does is that a perceptron, it at least takes one input signal, which is called X, and with a corresponding weight, W. So, and the weight shows the importance or priority of the input signal. For example, we can have different signals coming in, and one a particular neuron, artificial neuron, different signals. So now the perceptron has a way of trying to prioritize or give importance to, and also depends on the it depends on the weight that is associated with that signal. So and it calculates and sums of the input supplied by its weight. So the output of with those input signal. So, and apart from that, then the sum value will be passed into a nonlinear function, which is, and finally we get an output signal which is ready, which is known as y. So we'll see that. We can see that here. What I'm trying to say is seen here. So this is a diagrammatic view of that. So this is what a perceptron is. This is what a perceptron is. If you don't understand what a perceptron is, this is what it is. A perceptron has input signals and weights associated to each signals, and with that is being passed and thereby giving us an output. But here in this case, here, a neuron can take in different signals, just the way in neuron in the brain takes in different signals. And for example, I will give this illustration. If let me say an incident it happens now. So let us say a house is burning, and that is a soldier. Now, the first thing a soldier will first go and look for is his uniform. His uniform is priority to him, so he gets his uniform. So that's where we say that's the input signal. Also, he thinks about his certificate and so on. It thinks about a lot of things. So those are input signals. W1, W2, the weights are the importance given to each input signal. So the importance given to his uniform is is going to be very high. So, and that's what is the product of this input signal and the weight together added and given that the activation function will be what the neuron will give as an output to for the soldier to prioritize that. Okay, I think before I even go and save my certificate, actually save my military uniform, very important before any other thing. So now the weight is the importance or priority given to each input signal. So and with the mathematical formula for that equation is this. So and the diagrammatic explanation is this here. So I think we understand what I just explained. If you don't understand, you can ask a question, please.
Hello,
Please
sir.
proceed. Please proceed.
So now still on the perceptron. Now, but how to make the
Would not hear you again, please.